All right, so I think this is recording. Let's take a look at this problem. We're going to use the law of cosines. We cannot use the law of sines in this problem because I don't have a given pair. I know the measure of angle A, that's given to me as 22, but I don't know the length of A. I need to determine that, okay? And I know the length of C, that's 57. I know the length of B, that's 51. So this is our side angle side case. We're given two sides in the included angle. So that's when we're going to use the law of cosines. Now I'm going to start out by finding the length of A. So I go to my reference sheet and I see that it has A squared is equal to, well, B squared plus C squared, which is almost as thinking it's a Pythagorean theorem, but then since it's not a right triangle, I kind of think it as this adjustment minus 2BC cosine of angle A. See, when A is a right angle, 90 degrees, the cosine of 90 is 0, and you do have the Pythagorean theorem. All right, so I left a little bit of room there because since this is squared, I need to take the square root of each side. And I'm not interested in putting my plus or minus sign there. Since this is a length, I know it's going to be positive. So I'm ready to substitute these known values and then jump to the calculator. We've got 51 squared plus 57 squared minus 2 times 51 times 57 times the cosine of 22 degrees, not radians, degrees. So when I go to my calculator, let's make sure, let's double check that I am in degrees. Okay, I am, and I'm rounding it in this case to 3 decimals. Well, I may change that to 2. All right, so I'll take the square root, and 51 squared plus 57 squared minus 2 times 51 times 57 times the cosine. It understands implied multiplication there. All right. So I'm getting a length of 21.43, and that would be units of length, whether that's inches or centimeters or so forth. All right. So now I have a known pair. I know the measure of angle A, and I also know the length of side A. So it's very tempting to jump in and use the law of sines, and that is what I'm going to do. But if I have, remember, I'm going to use the law of sines to find an angle measure, which is going to involve me taking the inverse sine. I want to make sure I don't take the inverse of an obtuse angle. 57 is the longest side, so angle C is the biggest angle. I do not want to take the inverse of the ratio for the sine of C. I want to avoid angle C because it's possible it could be an obtuse angle. So I'm going to find angle B first, and I know that from the law of sines that the sine of B divided by B is equal to the sine of 22 divided by what I found for A, 21.43. All right. So, well, wait a minute. Why did that say B? When I knew this was supposed to be 51. It was given. Sorry about that. So I can jump to the calculator and take the inverse sine of this ratio, 51 times the sine of 22 divided by 21.43. So let's see what that angle is. The inverse sine of 51 times the sine of 22. It is important that I close that parenthesis and then divided by 21.43. It's not as important, that final parenthesis, because it'll close it for me. So I'm getting an angle measure of 63.06 degrees. Okay. So now I have two angles. Well, to find the third angle is super easy, because I know that in any triangle, the three angles have to add up to 180. So I can find the measure of angle C by taking 180 minus the sum of the 22 that was given and this 63 that I just found. And let's let the calculator do that work. I've got 180 minus that sum. So I'm getting 94.94 degrees for that last angle. All right, now I need to find the length of A, because it gives me the length of B and it gives me the length of C. But wait a minute, I already found A. Oh, hey, I'm done. Because they gave me two lengths, I found the third one. They gave me one angle, and I found the other two. Okay, so we're done with this. Now, you can stop the video now, or you can keep listening, because what if I had decided to not change to the law of sines? What if I just kept using the law of cosines? So let's illustrate that we would have got the same answer. Suppose that I was trying to find angle B by using the law of cosine. So I would have to use the formula that B squared is equal to A squared plus C squared minus 2AC times the cosine of this B that I'm trying to solve for. So you can already see that this is going to be a more complicated equation than our proportion was. But we can do it. So if we get this by itself, if we get this cosine of B by itself, well, that means that we'd have A squared plus C squared, and this B squared, these two terms would exchange places, and then I would have a positive 2AC cosine B over here and have to divide by 2AC. So there's the ratio for this cosine angle, angle B. I need to use the inverse cosine in the calculator, and let's plug in our values. We'll have 21.43, and that's being squared. The length of C was given as 57. Square it. We're taking away the length of B, which was 51 squared. And I have 2 times this 21.43 times this 57. So we have to be careful, just like we were careful over here, and keying it into the calculator. So if I use the inverse cosine, I'm going to put parentheses around this numerator. The 21.43 gets squared, and so does the 57. It gets squared. Now I subtract the 51 squared. Now that's my numerator, so I'm going to close that parenthesis, hit the division key, and in my denominator, let's put it in parentheses as well, so that the calculator knows for certain how to calculate both the numerator and denominator. And close the whole thing off. So this should be the same answer that I had for angle B just a minute ago. Now you can see that I had 06 over here and 05 over there. That slight round off is not a problem, right? We have the same answer. So when we find the measure of angle C, all we have to do is 180 minus this, and again it's just going to be a hundredth of a digit off from our answer in angle C when we had used the law of sines. So hey, I hope that helps with problem number 1, and I'll talk to you later.